Hi there! So last time we finished by talking about osmosis, which was a type of passive transport in cells. So we remember sometimes it's not the solute that passes the cell membrane, but instead it's gonna be the solvent. And most of the time the solvent that we're gonna be talking about is water. So we will look at what happened in this clinical case example that I gave to you, where we had this woman in her late 20s, and as part of the radio station competition called Hold Your Wee for a Wee console, she drank way too much water in a way too short of a time, which was not a great idea, and unfortunately she passed away. So let's figure out what happened to her on a cellular level. And to do so, we will be looking at red blood cells. But really, it could be any cell at all. It could even be a plant cell. I have just happened to pick the red blood cell as our example. So we will need to look at 3 different kinds of conditions. First one that we'll focus on is isotonic. So in an isotonic cell, we have as much solute inside the cell as we have outside the cell. There is going to be some amount of water moving into the cell and out from the cell. But overall, the amount of water remains the same. So the size of the cell remains the same. There's no difference between inside and outside. There's not going to be any difference to the overall size of the cell. How do you remember this? Well, I'll tell you one way. So if you think of the isotonic cells, we remember they did not need to grow, nor did they need to shrink. They are perfect size as they are. So you could say that these cells say that I so perfect. The next case that we're going to be looking at is going to be hypotonic cells. In hypotonic cells, we have more solute inside than we have outside the cell. You remember that we always try to balance off this difference. And how are we going to balance off if there's more solute inside? Well, solvent keeps rushing into the cell. So in this case, it's going to be water rushing in, trying to dilute this solute concentration, which is higher inside than outside. Well, consequently, if we put in more water inside the cell, the size of the cell will grow and it will swell until eventually it might even burst. Well, how do you remember that our hypotonic cells were swelling? Well, I always think of a hippo. Hypo sounds a little bit like a hippo to me, and hippos are these big, swollen-looking animals. The last case that we have to look is our hypertonic cells. In hypertonic cells, we have more solute outside the cell than we have inside it. And we remember we always try to balance this off, so we try to take water from the inside to outside to balance off the difference. Consequently, as we're losing water, the cell shrinks. It almost looks like it would dry up. So how do we remember hypertonic cells? What do you think of when you hear that someone's hyper? Well, they have a lot of energy. What do people with a lot of energy do? They run around. And what happens to the people who run around? They become skinny. So hypertonic cells were skinny cells. So there you have it. 3 different tonicities. Isotonic was iso perfect. I don't need to change because there's as much solute inside as there is outside. Next one was hypotonic cells. Hippo cells, the big swollen ones. And they're swelling because there's more solute inside than there is outside. And water is rushing in, trying to balance this off. And eventually, cell might even end up bursting. The last one we had was hypertonic cells. Hyper, lots of energy, running around, becoming skinny. So hyper skinny cells. And that's because we have more solute outside than we have inside. So water is escaping the cell. It shrinks and kind of looks like it would end up drying up. So there you have it. 3 different tonicities, 3 different explanations to what happens to the cell. And based on those, I challenge you to try to figure out what happens if you drink way too much water in way too short of a time and the outsides of the cell become diluted. There's less solute outside the cell. So have a go of figuring that out. That question might come up later. Thanks for joining me.